All right, today we're going to pull back the curtain on something that's fundamental to our digital world, network topologies. In other words, we're looking at the different blueprints for how all our computers and devices are connected so they can actually talk to each other. Let's dive in. I mean, it's a good question, right? It's not just a bunch of random wires plugged in willy-nilly. There's a real plan, a map that dictates exactly how information gets from one place to another. That map is what we call a topology, and it's basically the secret language of any digital conversation. So, here's the game plan. We'll start with the basic idea, the foundation of it all. Then we'll look at some of the original, simpler designs. After that, we'll get into the modern standards, the stuff you're way more likely to see today. And finally, we'll talk about how you choose the right design for the job. Okay, first things first. Before we go any further, let's get on the same page about what we even mean when we say topology. So, what is a network topology? Well, put simply, it's just the layout or structure of a network. Think of it like a blueprint for a house. It shows you where all the rooms, or in this case the devices, which we call nodes, are, and how the hallways, or connecting lines, link them all together. It's the how behind a network's shape. Okay, so with that foundation, let's jump back in time a bit and look at two of the OG designs, two of the earliest and most straightforward ways this was done, the bus and the ring. First up, the bus topology. Just imagine a single main road, right? And every single house on that street is connected directly to it. That, in a nutshell, is a bus topology. It's a really simple, linear design where every device shares the same main road, or in this case, the same single cable. And you can probably see the appeal, right? It's super simple. Because everything's on one line, it's incredibly cheap and easy to get going. But that shared line is also its Achilles heel. If two devices try to talk at the same time, their data collides. And even worse, if that one main cable gets damaged, the entire network goes down. Everybody's offline. All right, let's switch gears to the ring topology. For this one, picture a round table. If you want to pass a note to someone across the table, you have to hand it to your neighbor, who hands it to their neighbor, and so on all the way around the circle. That's the basic idea behind a ring topology. So in a ring, data just flows in one direction, like a one-way circular street. It's really orderly, which means every device gets a fair turn to send data. But, and this is a big but, it comes with a huge risk. If even one computer in that circle fails, it breaks the chain, and the whole network can just stop working. Okay, so let's put these two side by side and look at their critical flaws. With the bus, it's all about that main cable. That's the single point of failure. You cut that, the whole network is toast. But with the ring, the danger is everywhere. Any single device or connection failing can break the entire circle. So those early designs were fine for their time. But let's be real, today's world needs networks that are way more robust and reliable. And that brings us to the modern heavyweights, the star and the mesh topologies. Now, the star topology is probably the one you're using right now without even knowing it. Think about your Wi-Fi router at home. That's a perfect example. The best way to picture it is like a bicycle wheel. You've got that central hub and all the spokes connect directly to it. In a network, all the computers are the spokes, and they all connect to a central hub or a switch. And there's a really good reason this design is everywhere. If one computer's cable gives out, no big deal. Only that one machine goes offline, which makes finding problems so much easier. But it's not foolproof. That central hub is now the single point of failure. If your router dies, everything connected to it goes down with it. Okay, and now for the absolute beast of reliability, the mesh topology. If you want to picture this one, think of a spider's web. It's not just one path from point A to point B, right? There are tons and tons of interconnected threads. A mesh network works on that exact same principle. Yeah, this is all about one thing, redundancy. It's actually the same core idea that makes the entire internet so resilient. Since every device is connected to lots of other devices, if one path breaks, who cares? The data just takes a different route. This makes it incredibly reliable. But all that reliability, well, it doesn't come cheap. It's expensive and can be a real headache to set up. So we've got all these different blueprints, each with its own pros and cons. But what happens out there in the real world? Well, it's not always so clean cut. A lot of the time, network designers do a bit of mixing and matching to get the job done. And that's where the hybrid topology comes in. It's exactly what it sounds like, a mashup of two or more of the designs we've just talked about. So, for example, you could have a few different departments in an office, each with its own star network. and then you link all those stars together using a bus backbone. The huge win here is flexibility. I mean, you can literally build a network that's perfectly custom fit for whatever you need it to do. The catch? Well, as you can probably guess, trying to make all these different systems play nicely together can get really, really complicated and fast.
Okay, this table really pulls it all together. You can see the pattern clear as day, right? As you go down the list from bus to mesh, reliability shoots way up. But so does the cost and the headache of setting it all up. And hybrid? Well, that's the "it depends" option. Its stats totally depend on what you decide to mix together.
So there you have it, a quick tour of the invisible blueprints that hold our digital world together. Your home network, the Wi-Fi at a coffee shop, your office, they all follow one of these designs. Kind of makes you think, doesn't it? So I gotta ask, now that you know the blueprints, what kind of network do you think you're using right now? Thanks for